All right. So, as we start class today, there's only one thing that you can see right now in here. Well, I have something that I'm projecting its shadow of on the whiteboard. What is this thing? What do you think? What do you think it is? Hexagon right here. I hear hexagon. Anybody else have any guesses as to what this thing is that I'm projecting onto the whiteboard? Stop sign. I like relating to real items. Any other ideas?
A piece of bread.
A piece of bread, all right, honeycomb. Okay, wait. Will it help you if I show you a different shadow of this, maybe?
Yeah.
Okay, but close your eyes first because it might give it away in between. So just close your eyes real quick, and let me adjust something. I'll tell you when to open your eyes, and there will be another shadow of this thing that I have on the board in a moment. Give me a moment because my okay. That's about as good. Okay, here's the other shadow. Go ahead.
Oh, square.
Huh. So he said it's a square now.
Yeah.
Did it magically change? Anyone have any idea what this thing is?
Cube.
Ooh, some people had a guess right away.
Yeah.
Well, let's take a look at the entirety.
Cube. It is a cube. It is a cube. What? Rubik's cube.
That's interesting, isn't it?
Oh. Yeah. Oh.
What about the second shadow, or when I moved it all the way around, kind of helped you guys see that, oh, that's a cube. Anyone want to offer up just some specific things that helped you out? What was important that actually helped you notice this was a cube?
Because we saw four sides.
We saw four sides, so the second shadow helped you because we're kind of used to that, basing a cube off of four sides maybe. Anybody else, anything specifically that helped?
If we visualize it in our head, we can see when we turn a cube.
So you can visualize in your head how when a cube turns, what it actually looks like. What does it look like? What do we can perceive 3D, but do we actually see 3D like what I'm looking at right now? It's kind of a weird thing to ask, right? So our lesson is going to focus on shadows today. And yeah, I know, it's really interesting. I love shadows. Shadows are like one of my favorite topics to like play around with math. And there's a lot we can learn about shadows. You can tell here that just having one shadow of the cube wasn't enough information to quite be sure that that's what the figure was. It took a lot more of the different shadows of a cube for our mind to actually put it together into a whole complete true picture that that's what that actually was. So that's what we're really going to focus on today in this lesson. So pretty much the remainder of what we're going to do today is actually going to be based in groups of 3, and I have split you guys into groups of 3 ahead of time. So while I read your guys' names, if you'll please go ahead and just kind of move into those groups, and you can kind of stand with each other, and I'll get you going on what you're going to do next. So Robin Rose, Nathan Armenta, and Tristan Uribe. You guys can just, Nathan's right there, so Robin and Tristan, if you want to go over there, you guys can stand back there. Manasi, Jaslyn, and Mariah. Mariah's here, so Manasi and Jaslyn, you want to come over here? You guys can stand up because you'll have to stand up and do some moving around in a moment anyway. Trevor Payne, Emma Stiles, and Peace. So Emma, Peace, Trevor's right there, you can just join them. Chelsea, Rihanna, and Fariana. Chelsea's right there, and Rihanna's right there. So Fariana can move with them. And then Abraham, Hema, and Theo, our remaining 3. Okay, so here's what I'm going to do next for this activity is I'm going to give your groups a paper triangle. And what I would like you guys to do is, and I'm going to give you guys a light too, although a couple of my lights broke. I didn't have time to go get new ones. You don't have your phone with you that would use a the phone flashlight. It'll make something we do a little bit more tough later. Not that bad, but it'll be okay. So here's what I want you to do. I'm going to give you a triangle. I want you to cast its shadow onto the ground, and I want you to decide which of these triangles on the ground, you'll see them around the edge of the room there, which of them, the shadow of your triangle I gave you, fits the best. Okay, you got it? That makes sense?
Yeah.
Okay, so I'm going to give out triangles. Once I give these out, then go ahead and move. Oh, here's a light. This is the first 3 here's light. You want to use that light? Here's a triangle for your door. This is you 3. Okay, and here's a light. You 3. Here's a triangle, and here's a light to use. Do you guys have a phone? Does someone have a phone? You can use the light. And here's your triangle. Okay, go ahead and find your triangle, the one that fits the best. Okay? Find the one that fits the best. Just you can actually kind of just look at it probably.
Absolutely not this one. I think that one.
Yeah, look at the shape of your triangle.
Ah, congratulations.
Wait a second.
Oh, I know.
Okay, maybe this one.
Oh, is it?
Yeah.
Go ahead and play around with it a little bit for a moment. Have a couple.
Got it.
Go ahead and play around. Play around with it. How you can fit.
Come we go.
No, now you're making multiple steps.
Okay, here's some discussion questions I want you guys to think about and talk for the next couple minutes with each other about. I'm going to put them on the board. Okay, first one, can you find more ways to make it fit? You found a way to make it fit, I'm guessing right now. If you haven't, go ahead and try to find a way to make it fit. Can you find more ways? Can you find more than one way? Go ahead and play around with that first, okay? Go ahead.
Because if you do it this way, you do it this way. I mean, it's not really a difference, but if you think about it, yeah, because this side is switching to the other opposite side. And then it's like these, so like whoever was here, these lines, they were the opposite sides. Do you have any?
Here's your second discussion question. If so, what matters for how you hold the line of the triangle? If you can find more than one way. If so, what matters for the way that you hold things, all right? So try to be as specific as possible in your answering of this among your group, okay? A couple more minutes, 2 more minutes to discuss these 2 questions, all right?
The closer you hold the flashlight, the more the triangle takes up on the light.
Exactly, and the farther we pull it away, the like.
50% you're good.
What? Or if you.
No, look, it goes further.
Actually, it goes up and down. And it goes side to side. I'm actually getting confused by this. Wait, why are you not doing this? It's not. No, I know, but I'm not, because you see how it's like moving and then moving, or like just. Yeah, but also like, okay, but it's just basically like it gets smaller and then it gets bigger.
Whatever the shape is, you can see that it fits obviously like that. And if you move the shape closer to your face, the shape increases in size, and you can see it fit inside the outline. And if the farther it goes, it's smaller or bigger. It just uses your eyes to see the difference.
I like that description. Very, very specific. Cool.
90% sure we had the same explanation.
I think you got some specifics down for what you think
Yeah.
for this?
Yeah.
Okay. Have we kind of reached our time, guys? Feel like you've got a thorough kind of thought process from your group? Okay, well, help me out. I want to record some of the things you said. So first of all, well, I guess I won't be recording as much for this. Can you find more than one way? Can you find multiple ways?
Yeah.
Were you able to find multiple ways?
Yeah.
Okay, I think you should be able to find multiple ways to actually make it fit, which is kind of an interesting thing, right? Maybe you've never asked that question before. Probably not. You probably haven't been doing this with shadows before, but this is really the question I want to get at. If so if our answer is yes, if so, what matters for how we hold the light or the triangle? Just would somebody please be willing to share, Theo?
Well, basically what me and Abraham and Hema came up with, basically if you move the triangle like further down in the light, it becomes smaller, but if you move it close to the light, it becomes bigger. So
Okay.
the shape changes as like whatever, like how you
So the
hold
size changes depending on how far away you hold it. So let me ask all of you guys this real quick. Did anyone find the same thing, first of all? Kind of say the same thing? Okay, then from that, let's say you put it where it is fitting. Put it where it fits, more or less. Let's say inside the tape, on the inside of the tape. Okay, so she's got it where it fits. Help me out guys, if she moves the triangle closer, go ahead and move it closer. Sorry, closer to the ground. I guess either way is okay. Tell her, give her instructions. What should she do with the light now? Instead of the triangle.
Close to the shape.
Did that help?
Yeah.
So she said, triangle closer makes the shadow smaller. Closer to ground. Man, I keep forgetting that you guys and me I'm thinking closer to ground, you're thinking closer to the light. Then the shadow is smaller, and then what do we think about how the triangle and the light, do they have to work together? I guess that's a big question.
Yeah.
Did anyone mention the specific fact about them working together? Anything else that hasn't been mentioned yet that you guys thought interesting? Manasi?
We were were explaining how it has to be closer or farther. If we just have like a set distance between them, you can move it like proportionally altogether, as long as you keep that same distance between the triangle and the light.
Ah, I heard a couple important words. More, move. Interesting. Proportionally, you said,
Yeah.
or together. That's an interesting way of thinking about it.
As long as you keep the same distance.
As long as it keeps the same distance, you said?
Yeah, between the light source and the triangle.
Okay, so keep distances
Same.
same. And we'll explore this and see. We'll explore this a little bit and see. Anything else in particular you feel you want to show that we haven't mentioned? Robin or Nathan?
If you were to hold it like this, you can make it fit if you move the light differently.
Oh, if you hold it. Okay, so you say like this. Are you guys all looking at how she's holding it? Go ahead and can everyone see what she means by that? So when you say like this, what do you mean like this?
I mean, like this, if you shine the light differently, it'll fit correctly in the circle.
Vertically.
Her and then, yeah.
So how does that look different than how most of us are holding the triangle? I guess?
Holding it flat.
Flat, horizontally,
They're more tilted.
or maybe what's a good word to the ground? What's a good word in relationship to the ground if you're talking flat? Parallel too. Yeah, flat or parallel is great. So specifically, you said we could make it fit anyway. So you said triangle doesn't need to be parallel. My notes are a little scribbly here, but doesn't need to be parallel. Lots of interesting things that you talked about. So what we're going to do now is we're actually going to very specifically and formally explore what actually helps make the shadow so it fits or doesn't fit. That make sense?
Yeah.
We're going to actually assume that the triangles are going to be held parallel to the ground, okay? So horizontally. And we are going to play around, with an activity here that will help you deal with this. So I'm going to illustrate a little bit of what you're going to do. First of all, I want to tell you ahead of time, this really is important to be precise, okay? Very exact measurements you're going to take, and being as precise as possible is going to be really important. So can I get just one volunteer? Do you want to come up here, Chelsea, or, well, Fariana, whoever. I thought you were holding the triangle, but whatever. It doesn't matter. And just hold the triangle for me. Yeah, just hold parallel to the ground, and just hold the light too, actually. Or do you have your light on? You can use your light. So what you guys are going to do is you're going to actually be doing some measuring of some distances. Okay, I'm going to give you a worksheet as a group, and you're going to be specifically hold it a little closer here. The whole thing a little closer to the ground. When you guys are working on this and casting your shadows and taking your measurements, closer is easier to measure with because you're going to use a meter stick. So I'm going to give you all a meter stick, and I'm going to give you a piece of string, and there are some very specific measurements that I want you to take. One of them is going to end up being to go from the light source to the vertex of the shadow. Do you see that? Okay. Another one's going to be going from the light source to the triangle itself. And every time you take a measurement with a string, very, very carefully. That's not the front. Here's the front. Bring it to your meter stick, and then right here you can estimate 16.4 centimeters, or whatever the centimeters are. Does that make sense? Okay. So before I get you going on this, I'm going to give you a copy of this worksheet, and I'm going to have you all take a quick look at it to get an understanding of what to do before I let you go on actually doing all the measurements and stuff. So here's a copy for each group. It's you three? Okay, here's a copy for you guys. Go ahead and take a look at this with each other, okay? So you can be clear on the instructions on what's expected. So every one of you, please go ahead and get together and look at that. And here's a copy for you guys. And I'm going to hand you guys all a meter stick. Meter stick, meter stick.
What time you do it? So you can write down.
So you guys have probably already figured out that we need to distribute some roles here, right?
Yeah.
So here are the roles that I think will work best based on my experience in teaching this lesson in the past. I think it's best if hey, you all with me real quick? I think it's best if one person does the light and the triangle. I'm going to steal your triangle real quick, and then my light's right here. And it's tiring while people measure. It takes a little bit of time to measure. And you're welcome in between different trials on there, different ones. You're welcome to swap out roles if you want. But it's easiest if you're holding the light and the triangle pretty near the ground. If you do the real far away ones, the string's not long enough and stuff. So most of the things you do, keep them like within a couple feet of the ground. And this is probably easiest so you don't get fatigued so quickly. It's really important, whoever is the light and the triangle holder like me, that they are exactly holding these in the same position and not moving once, not moving a bit from this position. As soon as you make it fit, okay, as soon as you make it fit within, you have to be really, really, really careful. For me, it's probably easiest to do something like I'm doing right now. If I'm on a knee and then I do this and I just hold really steady, okay? That makes sense to you guys?
Yeah.
Make sure you guys are clear on what L1, L2, T1, T2 mean. In fact, actually right now, before I give you the string, you can use the meter stick to measure the T's. The table on the left. That's just the triangle side lengths. Go ahead and do that real quick, actually. Okay? Yes, you may. Yeah, we're going to grab you a pen. If I can see, that's the only one problem about being in the dark. Here you go. Anybody else need a pen? Everyone else has something to write with? None of you guys have one? So go ahead and do your teeth, your triangle.
Okay, so length, side, and side.
Okay, get going on your measuring. Get going on your measuring. You want to
You guys ready?
be fast.
Okay.
So
You guys have a string?
make sure you have somebody who's your measurer and somebody who's your recorder, okay?
7? Oh yeah, you're right, you're right.
Somebody's writing, somebody's measuring, somebody's operating the lights. So who's writing, who's measuring?
Somebody, whoever's in measure.
So you gotta do that
Hold it like.
in centimeters, in here.
Where's the string?
Oh, I thought you had the shadow.
Well, the shadow is going to be this, so you're actually measuring the length of the tape. So actually, for now, you just use this to measure the lengths of that and the lengths of that. Does that make sense? So the shadow.
Okay.
So it wasn't that clear. When I said shadow, hold on. The shadow is the tape triangle. This is what we're working on. I didn't clearly say that.
So it's trying to
When I said shadow, it's the tape triangle.
Oh, okay, okay.
Okay, that's the shadow aiming tape.
Okay.
I wasn't clear. When I said shadow, I mean the tape triangle. So you're measuring these sides and the tape triangle sides because you're forcing your shadow to fit this throughout this activity. Okay? Yeah? Yeah.
Can we just like measure this without the shadow?
Yeah, you don't need to use the shadow to measure. Yeah, I should have said that. I wasn't clear. Sometimes I forget some of these things I just say.
I don't know, 56.
Yeah, exactly. Just do that. Yeah, you can just do on the inside of this for each one, right? Yeah, so on this one, inside edge is the best. Oh, that's weird. I'm sorry.
18, 28.
28 for side 2.
You maybe erase it and rewrite it. Do it on top of this thing. Do it on top of this thing.
Measuring
Okay.
this is the shadow. This is whatever this is.
15?
15.
50.
You
Okay.
can actually catch the shadow.
Second side right here.
You can just put this.
16.
Really well. It's there.
Yeah, 16.5.
Round to the nearest
6. The small one, the smallest one.
Yeah.
Oh, yeah, right. Yeah, like 36. It's about 36. This one's about 36. Wait.
That's 40. It's 14. Wait, no. Wait, sorry. 41.2 centimeters that way. Something like that.
You can divide it, but actually don't worry about that now. You're gonna do next, you're gonna now start measuring L1. So find a shadow that fits. Your brother's your light and triangle holder is just very careful. Parallel and hold the light just perfect. And then the person who's the measurer is gonna put this in a place, whoever's gonna be measuring. It's easy to access. And you're gonna be measuring the long distance, okay? Well, it may not be long, but the longer distance, and then this one from the beam to that. Does that make sense? Yes. And you're doing that 3 times. So that's why there's
T1 divided by
you're doing that 3 times. 2 measures.
Okay, so 56 divided by 14.5.
Yeah, it is.
How exact do I need to go?
32.5.
I'd say the
Divided by
first.
what?
Yeah.
4.06.
Go ahead and just work on that then.
And then,
Yes.
what's your next numbers?
Yep, that's your T.
Yeah, okay.
It's the length of the side of the shadow. This is our shadow we're
Yeah,
trying to
and
measure.
then
Yeah.
this is the, okay.
So you've got your T2 is actually. Oh no, your T1 sorry is the length of the side of the shadow. So
Okay.
your T1 is the shadow length, and your T2 is the paper triangle length.
Okay.
Right? Yep. So just record those in there, and then go ahead and as soon as you're ready, get started on that one. I'll help you out.
Okay.
like directly above me, trying to be parallel to the ground. So we have to match it to this or just in general?
I think in general.
In general?
Yeah, okay. Double check those measurements again.
Well, let me find so that I don't move. Actually, this is probably better. Oh, there's a hair on my hand. That's lovely.
Just double check. Just double check.
Okay.
Just double check. Okay, are you ready to move on to the next things?
Okay, 46.
That's it. Looks good, yeah, that's great. Let's try and do what you guys are gonna do. Find the shadow that fits. Whoever your light triangle is, fit it in here. When I say fits, you want to fit it in here. So make sure that this, and so you
And then 46.5.
perfectly fit for the whole entire time the door's in there. Just not too long. And take the string. Did I give you a string yet? No. Oh, I forgot about that. Whoops.
Like all like T2 and that one.
Here's a string for you guys. Here's a string for you guys. Did you already do all the
Okay,
triangle size?
this is gonna be side one. This is 12.4.
And do you understand by this what you're gonna measure for all these? So this is your shadow, so you're gonna cast a shadow. And so whoever's your light person is holding really carefully.
Hold on. I'm trying to find so that it fits.
Perfectly. Yeah, and then whoever's your measure.
I don't think this triangle is.
This 3 times.
If I move it too much, this is it.
You can do the dividing later if you just do these first. Make sense? Okay, go ahead and get rolling. So here's your string, very good. A little bit nice and tight. Yeah, there you go.
I'm gonna measure just
Good job. Very precise. Precision.
the size from this side to that side. Wait, no.
All of the first 2 are out. Yeah, that's what I said.
No, because you have to measure the inside of it.
Yeah.
But.
It goes up to 36. Yeah.
That's what we have to do.
Yeah, that's what we did. We recorded that one.
Holding this and.
No, I know, but I'm just, okay. Never mind.
To cast the shadow. Whoever's your measurer, so you have a measurer and a writer, so you're a recorder, you're matching the different things. Do you understand what L1 and L2 stand for and stuff? Okay, so there's L2, no, L1's the long one, right? Yeah, L1, and L2 is right to the beam there.
Wait, is it from the triangle or from the light?
From the light beam to the triangle, that's L2. From the light beam to this triangle
L1.
is L1. Now you want to make sure this isn't fitting. Look, how to make it fit perfect. You see how there's so
Yeah,
much
I
space?
just
Yeah, I was touching it. So yeah, just do that, and then as soon as you're ready, be very steady and start measuring.
I think.
Hey guys, for time, I think we're only gonna do trial 1 and 3, okay?
Okay, 4. And then that's also.
Wait, hold up. No, my bad.
Okay, so for time, we're just gonna do these.
I'm waiting,
Don't worry
I'm
about
ready.
that. Okay? Yeah. So because of time, you can cross up the middle one. You guys you're writing all the measurements down. Right? You're starting it out.
Alright, now put it on.
Here, let me help you. Just hold that nice and carefully, and then now you can line that up there. So only do trial 1 and 3 because we're not gonna have that much time.
This one's a shadow.
That makes sense. Just click trial.
96.2.
So this is L1.
So, we did this side first, right?
Yes.
Just skip trial 2 and do trial 3 because our time is a little short. So.
Triangles still parallel to the ground.
You want to label that? Let's do. This is what I see.
Alright, and then 42 on the.
42?
Yeah.
Okay. Yeah. Alright, and then, so we need to do
Good job, guys.
next one.
Thank you.
Really precise. I love it. And you heard skip trial 2, right?
Okay, we need to,
Yeah.
from the light
Here, make it
to
fit.
the matching.
Good job. That's good work.
49. Yeah, 49.
I think we have to do that inside there and then measure it. Because this is just random. Or, no? You know what I'm saying, right? Like, inside there, we have to measure it from.
No, because it's not, you didn't do it there, it's like separate. This isn't like, yeah, it's not with the,
But then it could be like any distance.
that's why you have to be held it precise. And that's what he said.
Now you guys are doing the shadow on this, right? That's what
Oh,
I was
you
telling
asked
from the
that?
start. This is your shadow.
Whoa.
Okay, we gotta catch up. You guys are really behind right now, so I need you guys to be really fast to be catching up with this. Yeah, because otherwise it's just changing. This is exactly what we need to have. So yeah, try to be as fast as possible. Come back and help you, and I'll check out with you guys in a minute. How are you guys doing? You doing okay? Are you on trial 3?
No.
Okay, and this is the same distance as everything else, wasn't it, right? You're not moving any light or triangle? Good, okay, great. And you understand the distances and stuff? Yeah. Okay, go ahead and work with it.
2.95, 2.61, this is pretty close. 4.06 is 2.88.
So everything's about like 0.3 away.
Yeah.
Okay,
Everything's kind of
interesting. Trial 3. So different angle, but triangle still parallel. Kind of like this.
Okay. Oh, okay.
Now, not so far, Liz, but yeah.
Yeah.
That makes sense?
Hold up, make it match real quick. Yeah, okay. 9.2.
So listen, here, let me help you out real quick. Okay? You have that there? No, that's not parallel. Still not parallel. You have it tipped like this. There you go. Okay. Now, very carefully, keep it right at the same place. You need to measure right to there. How long is that? Oh, let's see how long it is. That's a little too long, so you're holding it kind of further than I wanted. I wanted just within a couple feet, so maybe try. Are we still only restarting one? Ooh, this is gonna be. We're gonna have to move faster. Don't worry though. You're not still way too far.
Further?
Yeah, quite a bit. Move your light. Yeah. Okay. Now let's move it over to make it fit. Okay. Let's just take a look. Let's at least try to finish trial 1. Okay. So here's how we're gonna measure it, right as close as you can. I'll call that good. 75.8. Okay. Now, I'll just do all the long ones. Go to this corner, and then to the light source, and then to the light source. And don't move that at all. 57.9. And then here, you can go ahead and do that. I was just reminding you. Okay, so then do the last long one I didn't do, and tell Abraham, and then do the 3 short ones, and at least we'll be with that.
54. Why'd you erase it?
Oh, that's a smart way of measuring. You just let go of one end because you started from the end, huh? I never even thought about that. That's actually a really good idea.
93.8.
Cool. All right. Okay, just a few more minutes. I'd like to allot to this. So, well, you guys are doing pretty good. Yeah. Remember, we're not doing trial today. I told you, right?
Should have 11. Yeah.
Good job holding that carefully. Are you guys all done trial 1 and 3? Do you notice anything interesting?
Stop it, guys.
Go ahead and do that.
Okay.
Yeah, go ahead and do that.
Very sorry.
Each of those. Sorry, it's so hot.
Okay, next one.
Breeze today.
It's going divided by 10, right?
Yeah.
What?
So it's T2 divided by 2.
Oh,
Just smaller one divided by 2.
Hey, you just lost your distance. That's not Oh, you're starting a new angle? That's almost straight on. Why don't you try it like that more?
So we do like this.
Just a hit. Let's try it more like.
Really bad.
yeah.
That would work.
Not every trial.
Yeah, no, the first one I did straight up, and then the next one I did leaning back.
Oh, you did it leaning back? Oh, my bad.
Do you want me to just
Nah, I don't care, whatever. Do whatever. Just,
Hey. My bad.
that's not your bad. That was my bad, actually.
22 point what?
What?
Just remeasure, it's okay. There's only those two one that you have.
Remeasure.
Yeah, let's wait, hold on. Let's just look at it a little more carefully.
Is that good enough or?
I need opinions.
Yeah,
Yeah, that's why it's kind of hard because it's like,
And then go ahead.
yeah, kind of hard. Okay.
Move it.
This though is not parallel. Remember the triangles need to be
Yeah,
parallel?
but also like if we like it depends on like the direction that we move it in because
Could
we
be.
found that like to the side is better. Like angling it to the side works a lot better than long
It
ways.
should still work perfectly if you keep the triangle parallel. Oh, well, also you have this oriented one. It needs to be this way.
No, like we had it the right
Oh, you
way,
did?
but like we were trying different angles and like only.
Yeah, there is more we can do with it actually. My light doesn't have a wide enough angle as much, but look, this still works. I have the triangle parallel and that fits really nicely.
Yeah.
But yeah, you're right though. There's other ways we can make that fit.
Okay, let's go get
Anyway, but if you already did your measurements, let's just get all the ratios done because we're gonna move on. You guys nearing your end? Okay, cool. Oh, sorry.
55.5. It's a lot of 0.5s.
Yeah, a lot of 0.5s.
Maybe they're getting smaller, but look at something interesting happening among.
Most of them are twos.
Now, if you did shorter, if you did,
I think you messed up on this one.
yeah, well, if you had the shorter ones here and the longer ones here, longer, shorter, I think you might have divided backwards on this one.
Oh yeah, I think so too.
So just swap it and record that again and then see.
It's 14.5 divided by 49.
Okay, so give me the numbers calculate.
You guys all done? Hey, are you guys done with your trial one?
Yeah.
Awesome. Go ahead for now. Oh, you're done with trial 3 also. Well, you guys move fast once you get done. Yeah, do all your dividing now.
Oh, should we round this down here?
That side and then.
Points. No, 76.1. Yeah.
Wait, did I just do that?
Yes, you did.
Yeah, I did.
No,
I didn't.
Oh, look at that, perfect. Satisfying.
20 point. I can't count.
Wait, did you lose it?
Yeah, I'm telling you, you were weak because you couldn't. Oh, beat her? Yeah. Yeah, it's okay.
Hi.
Hello.
59 divided by 9.2.
Oh,
6.41.
46.5 divided by 11.1.
yes.
Divided by what last number?
11.4.
That is 4.
Say what?
Oh, we can just tell me no.
Outweigh what?
Look at all the.
Maybe these ones are all fours.
Yeah, and then 2, 3, 4.
Maybe because this one isn't. We haven't done it yet. Right. Yeah.
Do you guys all are okay? Anything interesting that you noticed between anything? What's there? That's like almost.
Has your name
Yeah.
What? They're basically okay.
What do you think they're hovering around?
What am I doing?
What value do you think yours are hovering around?
Yeah. Yeah.
You notice that?
And then look at the middle ones.
So you
13,
think your values are hovering
14,
close?
13, 16, but still, whatever. And then this one's 12, 12. They're like they all have sort of similar numbers, except for this one here where it's 8, and then here where it's 16. But still, it still hovers around the same number. Yeah.
Interesting with outliers. I love that you're using the word outlier. That's actually a really important thing. You notice anything else?
Without the outliers, so. I think our estimates were pretty close. This one did change, like he said. This one was the same, but that changed lower than the 14 point.
I think these ones are really weird. I mean, these
The
ones
exact
look very,
ones?
very exact.
Well, it's because one of them was measured at a different angle.
But back in where we I don't know.
I feel like you just thought he gave us a big hand.
Ratios happening?
That's so weird though, because these are both 3, and these are like both a 3, and then these two are nothing to do with 3.
Let's pull together as a group. So you can, if you're still quietly finishing a couple calculations, go ahead. But let's pull together, everybody. Y'all with me?
Yes.
Okay. As you took all these ratios for all 3 tables, so we did the triangles themselves, and then we did the distances, and we did 2 different trials. Did you notice anything interesting?
They all hover around the same number.
They all hovered around the same number. I love that Tristan earlier said with outliers. I love the vocabulary use. Well, hopefully you noticed that. In fact, actually with all of you guys, I did notice that. weirdly, they hover around the same number. There's an important mathematical concept. Hey, are you guys with me again? Remember how I was just asked to pull together? So hold on, give me just a few minutes here. We good? Okay. It turns out that this is actually true, what you might have suspected here, that always, whoops, L1, the ratio of L1 to L2 is equal to the ratio of T1 to T2. In fact, hey, which of these distances was the easiest to measure most exactly? Precisely. The actual tape and the cardboard, right guys? Yeah, of course, that doesn't rely on you holding the light and stuff. And so this actually probably should give you your more true measurement, whatever yours is. So some of you guys are hovering around 4, some of you seem to be hovering around 3. And there's actually an important point I want to make. I'm going to introduce you to a type of diagram that you'll end up seeing in geometry type lessons. Let's say that I have the same cardboard triangle, and see if you can understand what this picture means. Do you see how this is a 2D version of what you guys are doing?
Yeah.
They don't have any questions for why this fits that, or are we okay? So it's important, we've talked about holding the triangle parallel. I'll use this notation we've seen before, the parallel. And I've shined, this is my triangle, and this is what? What does this represent? The shadow. So here's my light. But I could have taken the same shadow, okay? So we'll call this congruent with this, I'll use that little one, and it's going to be parallel. And what if I move this up? I guess that's a little bit too long, so let me draw that out there. Okay, and so that length, and they're all parallel to each other. Do you think that could represent the same triangle shining and casting the same shadow?
Yeah.
What do? We move the triangle and the light both, right? Or we could even do like trial 3 said and actually change the angle instead of the same shadow. So I'll still say that's congruent to the other one, and let's connect this and this here. Maybe that's approximately here. And that could even represent the same triangle, but having the light shown at a different angle, and you had to shift the triangle over like you did. There's a lot of important ratios that actually form here. So let's go ahead and think through some things. Suppose this is 2, and then you measure this of 6, and then we know this is 3. Talk to each other real quick. What should x be? Go ahead, talk to each other. What should the value of x be in that diagram? Because we just saw that the ratios are equal to each other. They're equivalent ratios. So if I know this is 2 and this is 6, and if that's 3, what should x be?
Oh, okay.
How long should that edge of the shadow be? Okay? So you just look at this and we know short to the long is 2 to 6, short to long 3 to something. Right? You can utilize this. Anyone have an answer up or up? We'll have a chance to think through together again in a minute. 2 to 6 is really a what? If we simplified it. 1/3 ratio? Are we all okay with that? So what makes a 3 to something also be a 1/3 ratio? Yeah, so we can tell that x in here should be 9. Now this is the crazy thing. If this is all the same triangle with the same shadow, all the ratios should be the same in all 3 of those diagrams. That's crazy. That's exactly what you guys were just doing. I know. So let's say a similar thing. I know this is x, and if this is, I don't know, let's say 7.5, and let's just keep the same. It's going to have to be 3 to 9 still, right? I didn't change this or this, did I? I couldn't. Yeah, it still has to be the 3 to 9. In fact, I can mark that here too, 3 to 9. Well, if that's a 1 to 3, x to 7.5, well, we could play around with that. I heard somebody actually already say it, but I set up where my long is on the bottom now, and we could actually be able to see, if we thought about those ratios, that would be 2.5. 2.5 to 7.5 is the 1 to 3 ratio. And similar thing here, if that's 5 and this is unknown, I guess what I mean unknown, I wrote something on my paper wrong, and this is 3 to 9, we could actually do a similar thing to figure out what that was, although, anyway, similar as this one, if this is 5 to something, then x should be 15. So we just looked at some simpler examples with this. I know that I've seen with you guys that we're good with equivalent ratios here. So the last thing we're going to do for today is an important, maybe more interesting, I don't know, thing. I'm going to give all of your groups real quick sorry, I'm just going to reach way over there. a new triangle, okay? I want you to see if you can force this triangle shadow to fit into your tape, onto that shadow, okay? Here you go.
I did it.
See if you can force it to fit. I'm just going to give you just a little bit of time. You gotta wrap up.
You know what?
Oh, you say the bent thing all the time.
We could try it.
I just have ice.
Like instead of holding it parallel, we can do
Or
it
if
like
we compare it to this one.
and then figure out which one's closer to. And then
I'm going to explain it.
Yeah,
I'm positive you can.
no, yeah.
We could put it from the corner from.
Can I see it?
Try to see if you can fit it perfectly. But remember, any way you can make the shadow fit's okay this time around. We do not need to hold anything parallel or do anything like that.
There we go, there we go.
See if you can get to where you can force it to fit.
We got it to fit. We got it to fit. What's it?
Hey, cool. Super awesome.
He was smart.
These guys are holding some crazy angles with their light and getting to fit. Oh, you guys are really near that too. No, it's really weird. Huh? It's super weird to like. You might have to be a real sharp angle.
Like that.
Oh yeah, that's good. I like that. Maybe you can adjust your distances. With the light, I think she needs. So like, let's try straight up with the light. And let's see if we can maybe get closer, maybe you might more angle. Or like adjust it to the side. Yeah, see what happens.
Hold on. The first part. Because we want to make this side the longer one.
Awesome. You guys made it fit too. Really good job.
So much man.
You're close. I'm gonna claim you could actually make it fit. And you're, oh, look at that. You're really near.
It's like a lighter.
So we're gonna, since we have to wrap up, our class period is almost ending here in a minute. There's a couple important things. Since we only have, well, actually not a minute. We have probably like a little over 5 minutes in this period. So notice that this one triangle, in fact, this just happens to be an equilateral triangle I gave you. Did you guys notice that?
Yeah.
Okay. This guy's shadow, I could make it fit any one of these random triangles that I had you guys, and you guys all had the same triangle. There's actually in math a difference between two words. A dilation is the special word for the shadow that holds the same shape. Do you get what I'm saying?
Yeah.
When we did it parallel, we actually call that a dilation. It's a special type of shadow. If I just talk a general shadow, a shadow could look like anything. It doesn't even have to look like the original triangle. And since you had all the same triangle, but each one of those cast a shadow that maybe didn't quite look exactly like the original triangle, if I asked you guys to actually like put all your triangles kind of together and combine them and see, kind of like the hexagon example earlier, I showed you more shadows than actually, I'm having a brain fart right now. Later, I only showed you one at first, and I showed you more, and the more you saw, the more you got a better picture of the true hexagon. My last thing to leave you guys with before I give you your quick exit ticket, your exit slip assessment, is math's full of life lessons. This is actually a really important life lesson, especially for today when we got so many people fighting around politics, but not just that, just so many people. Social media really contributes to people fighting with each other all the time. It's really important we understand each other. I'm going to draw a lesson out of this. Each of us, the way we actually view situations is really only a mere shadow of the truth of what that situation really is. But if we aim to understand each other, okay? If we aim to understand each other and each other's viewpoints, if I got my shadow, but then now I understand your shadow and your shadow, what do you think my combined perspective is going to be? Is it going to be closer to the true situation? Very likely it will if I gather more and more, right? Maybe, someone said maybe not, right? I mean, it depends if somebody's shadow is really distorted, right? But it still will help us understand. So math is full of things like this that we can learn from. It's really actually a useful thing for us to think about, that us pulling together and how we do view each other's shadows helps us get the complete understanding. So the last thing for today that I'm going to leave you guys with is I'm going to have you guys work on this exit ticket assessment individually. And